Hey everyone! In this video, we're going to look at how to describe bivariate data. So we're talking about two different sets of data, and we're using that comparison along the way. So in this case, now the big thing to know is between those two sets of data, we're going to have what's known as an explanatory variable and a response variable. So our explanatory, sorry, I'm stuttering over my words here. Explanatory is going to be our x-axis always. So in this case, we can think of explanatory as the x-axis. That's always the case. And it kind of explains why we get a certain response. So our x value is the response, or is our explaining the response that happens from the y. So between the two sets, we're always going to look and compare the two when we're looking at different unique situations, and we figure out what the story is there. But really, when we have this data, we're going to, instead of using socks, we're going to fudge it because this bivariate data is going to kind of come in a different form. So in here, this form can either be linear or curved. Okay, so every time we look at this dot, it's going to be having our dot plot on here, our scatter plots, and we're going to compare the form. The U in FUDS is going to be the unusual points. So we're looking for anything that stands out to us. It's unexpected. It's out of the ordinary. So anything that kind of gives us a reason to kind of talk about that. D is for direction. So really that's if it's positive or negative. So either way there, we're just looking to see if it's positive or negative. And then S is our strength. So we're going to talk about how strong, the stronger it is, the more linear it will look. So it means that they have a relationship that kind of is more direct. So if it's strong, it's going to be a linear relationship. And then the weaker it is, the more scattered it is. Okay, because that's going to indicate that the two variables don't really have much pulling them in the same direction. So we're talking about our bivariate data here, and again, FUDS. Instead of socks, we're looking at FUDS now because we're not looking at a distribution, we're looking at two pieces together. So as we're doing the double, we'll see that in the next example here. So in this case, we have a picture that represents the temperature versus chirp. So the number of chirps a cricket makes for a given temperature is shown on this graph. So we're going to go ahead and FUDS this. So when we look at it, we want to talk about FUDS. So I want to talk about the form. And we can see from this form, it's pretty straight, right? I can kind of get a nice straight line. Like most of my data will hit. It doesn't have to be perfect, but we're going to say it's on the straighter it looks here too, that linear relationship is going to have a strong positive connection in this case. Now, when I put it all together, of course, we want to always bring back context because if we don't talk about context, they automatically dock us on that AP exam. So really here on this next slide, you can see the association between temperature and chirps per minute is linear, positive, and strong. I don't have to mention anything about unusual points since we really don't have any. Like, again, if I kind of draw in a line roughly here that hits most of my points, all my points are pretty much in a place where they expect them to. There's a little bit that aren't perfect, but it's okay. Now, also, some people might describe this as temperature increases, the chirps per minute tend to increase. So that's what we're going to see. Notice here tends, because we're not going to say it happens every time, because of course there's always data that we could have that might lead us a different way. So we don't want to ever say that we're so sure. We always kind of add those like about, approximately, those kind of terms in there. So just make sure we don't put anything too perfect. In the next one, we're just going to FUDS it again. This time it's for approval rating versus the margin of error. So what I mean by that is presidents over time who have run for re-election, okay, we're looking at the approval rating versus the margin of error that they won or they lost. So in here, our data is not as strong as we saw the last time, right? So we can see that it's still following a linear pattern. It's not really too curved. I mean, it's not as nice as it was before, but we can kind of get that line kind of in there that's close to most of our data. So in here, when we're talking about this, we can look at our approval versus our margin, right? We can see that on there. It's all the two different sets of data are there for us. So as I look here, what I'm going to do when I go to describe it, when I go to actually FUDs it here, again, we start with the context. So the association between the approval rating and the margin of error for victory or defeat is linear, because we're still seeing that line pattern. Like if I can kind of get a line that kind of hits most of my data in there, it's positive. So we talk about the direction, and it's moderately strong. Now, I'm not really seeing anything that really is too unusual. But if I went back, like I can kind of argue that there is one that maybe is a little low for the margin of error, right, compared to the approval rating here. So in that case, if I went back to the data that this context had, that one represented Nixon. And we can say Nixon had an unusually low margin of error for his win given his approval rating. But in this case, too, if you didn't mention that one, I can understand that here. But if you thought that stood out to you, you could always add it. Maybe you see another point that kind of stands out to you and you think is unusual. You could always go back to the actual set of data here, like that would be provided to plug these in. And we can kind of talk about that in context as well. Now, when I get to this next one, this is representing the percent of states where people eat 5 vegetables a day versus the people who smoke. So it's those two percentages here. And we kind of don't see that linear pattern that we had in the previous two. Like it's like over the last couple, we've kind of gotten weaker. So because it's not modeling something linear in this case, I'm going to go with this being a weak correlation, right? It's kind of not even curved as much. So maybe when I'm looking here, the association between the percentage of people in states who eat 5 servings of vegetables per day versus the percentage of people who smoke, even though it's like not linear to say, it's really not curved. Like I can kind of fight to kind of get a line that would go in here, maybe a little bit more like this. But because I'm not following, it's like the curve that I'm talking about is like more of a pattern kind of idea. But the big thing here is noticing that this is weak, right? It's not following a uniform pattern. We're not really seeing anything out there. But so we want to definitely talk about those things. So remember FUDs. So form, direction, and strength are right here. But also remember that now I do have an unusual state who had a low percentage of smoking for the given of those who serve here. Like if I look at this piece here. Now, if you're curious, that was Utah. So in this case, that low percentage of smoking is kind of unusual compared to the rest of the data. We can still kind of force like a pattern in there. We can just see that the general direction puts us negative in this case. But the more scattered their data is, the weaker it is. So really anything that's strong, that means there's some kind of connection maybe, is if it goes in the same direction, more like a line. So this is all going to be kind of linear pieces we're looking for, linear or curved. Now, additionally, there's something that we need to worry about kind of like with lurking variables. So in an example, there was a fat versus life expectancy. So it was saying like the amount of fat consumed within currency in different countries. Like I think it was 40 different countries they looked at, but they took the fat that was consumed, compared it to the life expectancy. So roughly, because it was talking about the fat consumed, that was my explanatory variable. The response variable was life expectancy. But that data didn't really follow a straight line. That data actually kind of follows a curve pattern, something like this, roughly. Now, we kind of look at that and we think, well, why might that make sense? Why could that be a thing here? So when I'm going through that, it kind of feels like weird to us because we're thinking here, what we think about as far as in the United States, the more fat you consume, maybe the less likely you are to kind of have a longer life expectancy. Because it's like we're kind of thinking about it, the more you take care of yourself in that sense there. So as I'm thinking here, you kind of get a little nervous on this one. So there's something known as a lurking variable. So that is totally something we got to think about in a second. Let me give you a comparison, and then we're going to come back to this one, though. So one of my favorite lurking variable exercises here There is a statement out there that says that the relationship, the association between ice cream consumption and manatee deaths are linear, strong, positive. So when I'm thinking about that, I have here ice cream sales, and manatee deaths. Now, they have a strong linear positive correlation. So let's think about this for a second. If I see something like this, and I was told that, does that imply that eating ice cream will kill a manatee? No, right? That's crazy. Right? We can eat ice cream and it has no effect on our manatees whatsoever. At least we hope it doesn't. But really what happens is we have to think about some other variable but that might be kind of weighing in that we're not realizing. And that's the whole idea between a lurking variable. It's something that's not distinctly talked about in my graph here, but it's something that might be the reason or like a kind of cause for why something could have just changed this. So think about when you're eating more ice cream, probably in the summer. And what else happens during those summer months? Maybe there's more recreational water sports, like we're going on boats, we might be going fishing. Maybe we are just going on the boat more. Anything like that could cause to like some accidental manatee deaths as well. So there's some that lurking variable in this case is the season. So our manatee deaths, they're not necessarily the cause of the ice cream sales and vice versa. There is something else that's happening. It's the season. It's the summertime. It's nicer for us. And we just kind of have that in a different place. So a lurking variable is something that isn't in our descriptor, but that could have some cause to what's going on in the case. So really, anything technically could have a lurking variable, even if it's not something that seems like there'd be one. So we have to really make sure that there's one really big thing that makes sense about these correlations here. Our association, whether it be strong or weak or anything in between, association does not imply causation. Okay, so no matter how strong you're looking at there, whatever that data is, it does not imply causation. So sure, there can be two types of things we look at that maybe could be justified in having a cause, but there's situations like this that exist that tell us straight up that association does not imply causation. And that's one of the biggest things about this unit that we have to kind of keep with us. So if I go back to our previous problem with that life expectancy and the fat consumption, if we think about it, it had this curve pattern. We're wondering, like, well, what's happening here? Like, how is that even possible that the more fat you consume, life expectancy increases? That feels a little bit weird. But what happens is it's really depending on your country you're living in. So it could be about your socioeconomic status. Like if you have more money, you can consume more fat and you'll probably live longer than someone who's experiencing poverty, where they can't afford to buy like more fatty foods and get that quality. Like they probably won't live as long. So in this case, depending on it, there was that lurking variable in here about that. So we always have to watch out for that. So our big idea too is just that if we know what a the lurking variable definition for us, it's a variable associated with two other variables in such a way we may mistake causation. So again, the lurking piece is that hidden factor that has an effect on two different variables that we might not recognize, and we might feel like there is a cause, mistake it for the causation. So that's why we can never really use association to imply that causation. We kind of have to think about the fact that there might be a hidden factor in there. All right. So basically, our idea when we're talking about and describing our bivariate data, the two data together, we have a explanatory and a response, right? We start with those two, and then we fudge it. We talk about the form, any unusual points, the direction, and the strength. Okay? The strength is the closer it is to something linear. If it's scattered, it's weak. But we just look for the direction, whether it goes up or down, positive, negative, and if it's linear or curved. Okay, so remember, we can have those weak moments. So even if like our data is scattered and doesn't look like it's linear, it still could be, and we can talk about it, but that's why we mentioned the fact that it's weak. So for this last part here, I want you to go ahead and for each of the following, determine the explanatory variable and the response variable, and draw a possible sketch of each of the following. So do that last part tonight, and then we'll talk about it in class tomorrow, and we'll see you then. All right, thanks for watching.